In problem quiz 6, we're going to look at some of the calculations that one might have to do if one were working with buffer solutions. All right, this is an example of multiple equilibria at action at the same time. And one of the key equations that we need to be comfortable with in this particular module is the Henderson-Hasselbalch equation. Okay, it's written out down here. And what that equation tells us is that the pH of a solution that contains appreciable quantities of both an acid and its conjugate base is going to be equal to the pKa of that acid plus the log base 10 of the ratio of the concentration of its conjugate base to its undissociated acid. All right, so the key here is that we have appreciable quantities of both of these species here. In a buffer, typically this ratio is going to be close to 1. All right, so that would give us the maximum buffer capacity. All right, in this particular problem though, we're told what the pH is, so we're given this number, and we're given the concentrations of the weak acid, undissociated, and its conjugate base. So we're given both of these concentrations, and what we're asked to solve for is the pKa. So now what I need to do is I need to rearrange the Henderson-Hasselbalch equation. So in essence, what I can do is subtract this logarithm term from both sides. And when I do that, I would end up with an equation that looks like this. Right, where this is the same ratio of those concentrations. All right, so now how would we fill this out? Well, what I want is pKa. What I have as pH is 8.485. I have log base 10 of the ratio of 0.5 molar divided by 0.350 molar. And so when I figure this out, I'm going to get 8.485. And when I calculate this ratio and take the log of it, I should get 0.155. Now you'll notice that this is not very large. That's indicative of a buffer solution. This ratio, the closer it is to 1, if it were 1 it would be 0. So the closer it is to 1, the closer this number will be to 1, and the less it changes the pH when you create that buffer. All right, so in this particular case, the pKa for this particular solution is 8.330, and that would be the answer to this problem. All right, so you should work on different combinations of things that you might be given. For example, you might be given the pKa and the pH and one of these two concentrations, and you would need to find the other. All right, there are all kinds of problems that can be created from this. But this particular problem will get you started at least in figuring out how to solve these kinds of problems and to become comfortable with them.